Hello and welcome to the Swine Disease Reporting System. My name is Guilherme César, and today we're going to talk about the PRRSV ORF sequence page from the SDRS report. When you open the report in the page 3 on your left-hand side, the first chart that you're going to see is the number of wild-type PRRSV ORF sequences detected by month. In this chart, you can see the monthly count of ORF sequences that are coming from the 6 participant VDLs in our database. And then we characterize these sequences as wild type when they have less than 99% similarity with the MLV vaccines that we have circulating here in the US. So basically, we compare this sequence with the OR5 of the MLV vaccines, and when you see less than 99%, we consider as a wild type. And then you can see that we have 3 different colors here in this chart, so you can see where these sequences are coming from. If you see the blue colors, because it's coming from the adult sow farm. If you see the unknown, it's because the veterinarian, the producer, didn't specify in the submission form which site the sequences were coming from. And then when you see the red color, is coming from the win to finish sites. The second chart that we have in the report is the number of PRRSV ORF sequences with less than 95% similarity within the SDRS database. You can see that it follows the same color pattern as we have in the previous chart, but I'm going to explain more what does mean this 95% similarity within the SDRS database. So to be considered for this analysis, we have 3 specific criteria. And the first one is that this sequence, this OR5 sequence, as you can see in the example here on the right side, it must have from 597 to 606 nucleotides. And we picked the specific numbers because the PRRSV 2 or 5 usually has 603 nucleotides, and the PRRSV 1 usually has 606. And some mutations can happen, and that's why we consider this specific number from 597 to 606 nucleotides. So if the specific sequence has less than 597, as I'm highlighting here in the red color, this sequence is removed from the analysis, so we do not consider from the SDRS database. And also, if it has more than 606 nucleotides, we also remove from the SDRS database for this specific analysis. So the sequence is not considered, as I mentioned before. For the second specific topic is that the number of ambiguities, it has to be less than 6. So what is an ambiguity? Usually when you are sequencing one of these OR5, you can get these specific letters as I'm showing here on the left side of the picture, the letter W. When you don't know if it's one of these specific nucleotides, so A, C, T, or G. So if you don't see one of these, this is considered an ambiguity. And we use this specific cutoff of 6 for quality control, and also because sometimes you can have more than one sequence in one sample, and these ambiguities start to happen, so you cannot characterize well this specific sequence. Just to show you an example on how we remove a specific sequence with more than 6 ambiguities, that would happen here in the red color that you can see in the sequence example, and these specific sequences are removed from our database. And then finally, when we have all the database clean, we start to compare one sequence that enter in the database with all the SDRS sequences that we have in our database. And then when this sequence has less than 95% similarity, then is the sequencing that is included in the chart that I presented before. So just for you to have an example, when a sequence comes inside the SDRS database, you can see the ID of the sequence and the year specifically, and then you can look to the similarity degree here. And you can see that these 3, they have 94, 94, and 93 specifically. So these specific sequences comes to the chart that was presented before at the beginning of this presentation. Then the third chart that we have in the SDRS is the PRRSV lineage and RFLP patterns detected throughout the year. So this is a cumulative count from the year of the respective year that we are analyzing the data. And with these, you can see which sequence is more frequent detected in the SDRS. And this is combined the lineage and the RFLP that are results of the specific sequence that we have from the VDLs. and then we can make this count and make this cumulative count throughout the year. And finally, one of my favorite charts of this page, that is the most frequent parvovirus strains detected across US states. So these, if you are from a specific state here of the US, you can double check which specific sequence is more frequent detected, the second most frequent detected, and the third most frequent detected. So you can just take a look in the specific state that you live or you have the operation of your hog farm, and you can see which lineage and which RFOP are circulating more predominantly in your area. So if you like the information provided by the SDRS report, you can just scan the QR code here and start to receive the monthly reports in your email. Thank you.